All right, let's just dive right in. We're all online every single day, right? But have you ever really thought about how your data actually gets from point A to point B? We're about to look at a pretty revolutionary idea that's changing the very rules of that game. It's called network coding, and honestly, it's like a secret, super smart upgrade for the whole internet.
So what's the big difference here? Well, traditionally, you can think of the little connection points in a network, we call them nodes, as simple mail carriers. They just pick up a packet of your data and forward it along. Unchanged. Simple. But network coding completely flips that script. Now the nodes are more like master mixers, They're actively and intelligently combining different data packets together before sending them on their way. It's a massive shift from passive to active.
So here's how we're going to break this down. First, we'll look at the problem, the network traffic jam. Then we'll get into the fundamental shift that helps solve it, see what that really gets us, peek under the hood at how it all works, and finally we'll ask, what does this all mean for our digital future?
Okay, first things first, let's really get a handle on the problem we're trying to solve here. We're talking about the classic network traffic jam, and why the old way of doing things, well, it just doesn't cut it anymore.
Think about a traditional network node. It's kind of like a traffic cop who can only wave cars straight through. It just forwards whatever data it gets, totally unchanged. This creates all sorts of bottlenecks and slowdowns because the system is, by its very nature, passive. It can't adapt, and it definitely can't get creative with how traffic is flowing.
So to fix this, we needed a whole new way of thinking. This isn't about some tiny little tweak, no. This is about a fundamental, ground-up shift in how we even approach the flow of data itself.
And here it is, network coding. So instead of just passing along individual pockets one by one, the nodes in the middle of the network are now actively taking different streams of data, mixing them together with some really clever math, and then sending out a new combined packet. It's all about making every single point in the network an active, intelligent player in the game.
And that's the million-dollar question, isn't it? I mean, it sounds cool, but what's the real payoff for all this extra work? What do we actually get by turning every node into a data mixer? Well, it turns out the results are pretty amazing.
The very first and maybe the most obvious benefit is just a massive boost in performance. We are talking about getting way more data through the exact same pipes and getting it there a whole lot faster.
What this really means is that by smartly combining packets, we drastically increase the network's throughput. That's just the technical term for how much data it can handle. Think of it this way. Instead of sending two separate trucks down the same highway, you find a way to combine all their cargo into one super efficient truck. You're using the same road, but you're moving a lot more stuff. That's exactly what network coding does for data.
But you know what? It isn't just about speed. This whole approach also builds a network that is fundamentally smarter and a whole lot stronger. And this is where things get really interesting.
This active mixing gives us at least 3 huge wins for what we call robustness. First, you get way better fault tolerance. If one data path gets blocked, the mixed data on other paths can often still be used to figure out the original message. Second, it opens up brand new possibilities for security and making sure your data is what it says it is. And third, it just makes the whole system much more resilient when packets inevitably get lost along the way.
Now, this whole mixing thing creates a really fascinating security puzzle. In a normal network, you can digitally sign a packet to prove it's the real deal. But how do you verify a packet that's supposed to be changed and mixed up along its journey? Well, the solution is just brilliant. You don't sign the individual packet anymore. Instead, you sign the mathematical properties of the combined data. This is how you can protect against a bad actor trying to sneak malicious code into the mix.
Okay, so we know what it is, we know what it does. But how does a node actually mix data packets? How does this happen? Let's take a quick peek under the hood, shall we?
So the most common way this is done is with a technique called random linear network coding, or RLNC for short. Now, don't worry about the complex name. The concept is actually pretty straightforward. The network basically treats data packets like mathematical vectors. Each node then creates brand new packets by just making random linear combinations of the packets it's already received. Then, all the receiver needs to do is collect enough of these unique mixed packets, and it can solve for the originals. It's a really systematic mathematical way of mixing and unmixing.
And this breaks it down perfectly. A node receives a few different packets. It does its linear combination magic, creating a single new packet that has information from all the originals baked inside. Then, it just sends that one super efficient combined packet on its way.
Simple in theory, right? But incredibly powerful in practice.
This quote from the original research paper, it really gets to the heart of the huge conceptual leap here. You see, instead of just sending individual data points, or vectors, network coding sends entire mathematical toolkits, or vector spaces. It's kind of like the difference between shipping individual Lego bricks versus shipping the blueprint and all the bricks you need to build the entire castle.
So, let's bring this all home. What's the one single thing you should really take away from all this? And what could it mean for our future?
Look, if there's one single takeaway from our entire discussion, it's this fundamental shift from a passive to an active network. We're moving away from a simple system of tubes that just forwards data, and we're moving towards an intelligent grid where every single node helps make information flow more efficiently, more robustly, and more securely.
And that just leaves us with a really fascinating final thought to chew on. We're building networks where data packets can basically heal themselves if parts get lost, where information can flow like water around obstacles, and where security is literally baked into the fabric of the system. So if our data can do all that, what new applications, what new technologies, and what new possibilities does that unlock for every single one of us? It is a very exciting future to think about.